For the deposition of gold wells on silicon, we have a silicon wafer, an aluminum mask, and a set of 4 aluminum covers with distinct sizes. On the silicon wafer, we attach the aluminum mask using, for instance, double-sided tape. The same can be done to attach the covers to the mask. In this configuration, we deposit a thin layer of chromium for adhesion of the gold films. Those will be deposited later. I recommend a maximum chromium thickness of 0.1 microns. It could be thinner to the limit that guarantees adhesion of the gold film. We obtained this first structure with our regions coated with 0.1 micron thick chromium. Next, still without any cover on the mask, we make a first deposition of 0.5 microns of gold in all exposed regions. We obtain this new structure with all uncovered regions having a 0.5 thick gold film. Next, the largest cover is used to block the 4 inner rectangular regions. With this configuration, we make a deposition of 1.5 micron gold, which will coat only the 4 lateral spacer regions. We obtain this new structure. Let us remove some of the spacer layers for a better view. The result is a 2 micron thick gold film on the spacers, and 0.5 microns of gold is maintained on the central layers. Let us put back the other spacer layers just to have a look at the actual configuration so far. Now the next thing is to remove the largest cover and use the smallest cover to block the first inner rectangular region. You have to be careful not to block any lateral spacer region in this operation. With this configuration, we make a deposition again of 0.5 microns of gold, and then we obtain this new structure. Now the spacers have gold 2.5 microns thick, and the regions that were exposed now have gold film that is 1 micron thick. Now next, without removing the smaller cover, we just attach the next cover size as shown. We then make a new deposition of 0.5 microns of gold. We thus get 3 microns of gold on the spacers. Now we have 2 regions with gold 1.5 microns thick. One region has 1 micron and the other has 0.5 micron gold film. Next, one more time, without removing the previous covers, we attach the next cover size as shown. We then make a new deposition of 0.5 microns of gold. Now we have, after this step, 3.5 microns of gold on the spacers. Only one space is shown in this picture. And the 4 inner regions now have gold films having thickness that go from 0.5 to 2 microns in steps of 0.5 microns. Let's just put back those spacer layers. One more time, without removing the previous covers, we attach the largest cover, blocking again the inner regions. We then make a final coating with 0.5 0.1 micron of chromium, but only on the spacer layers, as the inner regions are blocked by the cover, by the aluminum cover. We get this final configuration with the spacer layers having an additional chromium layer up to 0.1 microns in thickness. We then dice the wafer along the edge of the aluminum mask. So this is the final chip shown on side view, and the thickness values shown include the addition of the chromium layer. In fact, the absolute thickness of chromium is not that important, as the step thickness difference between inner layers is kept fixed at 0.5 microns according to this procedure.